Last video for our review packet for Unit 1A. And here I'm going to be solving. So I need to isolate x and make sure that I find a value that can be substituted into these equations to make everything true. So for number 22, I first need to start with distributing my negatives. So I have 3x minus 2x minus 4 equals 3 minus x. And I want to combine like terms over here. So now I have x, when I subtract these, minus 4 equals 3 minus x. All right, so I'm going to just move a few things over. I want to add 4 to this left side, so I get rid of my 4. And then I also want to move my x over to one side so I can have everything isolated. So I'm going to add an x and add an x. So now these go away. Okay, so I'm left with x plus x gives me 2x equals 3 plus 4 is 7. And again, I need to get x alone, so I'm going to divide it by 2. So this cancels into a 1. So I am finally left with x equals 7 halves. All right, so number 23, this is a quadratic. So either I can factor this and solve for x, or I can use the quadratic formula. I'm going to first start by trying to factor it. It looks like this can be done. Okay, my two factors will be always set equal to 0, so I can solve. All right, so whenever we have a coefficient in front that is larger than 1, you can kind of draw this little x to the side. And what you want to do is you want to multiply the first and the last term. Okay, so 18 times negative 4 is going to give me negative 72. And then, as usual, we want to always think of what are two factors of negative 72 that will add up to my middle term, a positive 21x, or 21, I'm sorry. So 72, I can break that down to 3 and 24. Okay, now I want a positive 21, so I know that I need a negative 3. I'm going to take that away from 24. So this is a little bit helpful. This kind of helps you figure out what your outsides and your inside terms need to add up to or multiply to. Okay, so I know that I have 18 here, okay, but I know I need two terms that are going to actually multiply to 24 and to 3. So it's just kind of helpful, all right, because if you think about 18, 6 and 3, 6x and 3x are going to give me 18. And you think about terms of 4, it could be 2 or a 2 or a 4 and a 1. But I definitely need one of my outsides or insides to multiply to 3. So I'm going to go with a 1 here and a 4. So look at this. 4, 3. I'm sorry, 24 when I multiply 6 and 4 and 3. All right. This sign being negative is telling me that I have a positive and negative binomial. So I just have to ask myself, which one has to be negative and positive? I know the 3 needs to be negative, so I'm going to put the negative in front of the 1 for my insides and put a positive here. Okay, so this works out. Double check it with FOIL if you need, but now each factor gets set equal to 0. And 3x plus 4 equals 0. So I'm going to solve. So I have x equals a positive 1/6 and x equals a negative 4/3. All right, so these are my answers. You can always write a lovely solution set because you have more than one answer. All right, there you go. Okay, 24, our lovely radical. So I want to get rid of this square root. And one of the first things I want to check for is this radical isolated, which I'm very lucky it is. Okay, so I can then start my next step of squaring both sides. Okay, so now when you square a square root, it goes away. So I have 5x plus 4 equals 2 squared is 4. Okay, and I'm going to isolate. So I'm going to subtract 4, subtract 4. So now I'm going to be left with 5x equals 0, because this goes away, but this also turns into 0. I want to divide by 5, but really I know that x is going to be 0. All right, what's the biggest thing now? Check, 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 check. Before I make sure that this is my final answer, I have to check. All right, so I'm going to plug 0 back into this equation. So I would have 5 times 0 plus 4, and that needs to equal the square root of 2. 5 times 0, that's going to cancel out to 0. So the square root of 4 equals 2, absolutely. So yes, this is my final answer. All right, absolute value. This is jail. Remember, it needs to be isolated as well. So first I want to get rid of my 8. Then I'll get rid of my 5. Remember, it's like we're dissecting this. So the 8's kind of pushed to the side, so we can add 8 to both sides, so it cancels my left. And right now I have 5 in absolute value x minus 5 equals 10. Now this is being multiplied to this, so I have to divide it out to cancel it out. So now I have x minus 5 equals 2. So finally my little jail cell, my guy can come out of my absolute value, and he's going to go positive, or he could possibly be negative. That's an equal sign there. All right, so I have to solve each one. So I'm going to add 5 and add 5. I'll do it to both of these at the same time. Okay, and I have that x then equals 7, and x equals 3. So 3 and 7 are my final answers. All right, so number 26. Lovely rational problem. We want to get rid of that denominator, okay? So if we can find an LCD, we can cancel that out and make our lives much easier. So I got to figure out 8x and 3. All of these have to go into the same value. So I know 8 and 3 can go into 24. So our LCD is actually going to be 24x. So I want to multiply every single term by 24x. Another way to think about it would be make sure the denominator is 24x. So if I'm looking at 2, that is my first term. Technically it's 2 over 1. The denominator is just a 1, and it has to turn into 24x. Therefore, I need to multiply this entire 2 by 24x. So I have 48x. All right, now we're looking at the next term. 8x. In order for 8x to become 24x, I need to multiply this term by 3. So 5 times 3 is 15, but do not forget the negative, so minus 15. And then the last one, I need 24x, need to multiply it, but I already have a 3 down here. So I need to multiply this by 8x to get to 24x. So 5 times 8x is going to give me 40x. And now from here, I can rearrange this and change it all around. So I'm going to add 15. Oops, I tried to change colors there. And I'm going to subtract 40x. All right, so I have 8x, this goes away, equals, oh, this doesn't go away. Oh my gosh, I apologize, I'm going too fast here. All right, so I'm adding 15, so I have to make sure I add it over here. This goes away, is what I meant. So 8x equals 15. All right, now I just need to divide, so divide by 8. So x equals 15 over 8. All right, and last but not least, here I have another quadratic, but I do want to make sure that this is 0. So I have x squared minus 6x. I'm going to move over my 7 by adding it to both sides. So my right side can become 0, and now I can solve. So if I try to factor this, let's just think about it. 2 factors of 7, okay, are going to be 7 and 1. But this is telling me that both of my binomials that I would factor this into have to be negatives. So if I had a negative 7, and then I would subtract another 1 when I FOIL, this would actually have to be negative 8x. So I cannot factor this. Therefore, I get to use my lovely quadratic. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over that entire quantity all over 2a. All right, and here my a is a 1. We're looking at the coefficient in front of x squared. My b value is a negative 6. That's always going to be the coefficient in front of x. And my c value is a 7. So I'm going to take all these values and plug them directly into this equation. So opposite of b is going to be 6 plus or minus the square root. B squared is going to give me, whoop, hold on, let me fix that. Okay, negative 6 squared minus 4 times a is 1 times c is 7. All over, let's make sure we have this, 2 times 1. I'm going to move this down a little bit, get more room. Okay, so I have again 6 plus or minus. Now we're going to simplify this a little bit more. So we got 36, and then 4 times 7 minus 28 all over 2. Okay, so 36 minus 28 is going to give me 8. So now I'm going to move down again. I have 6 plus or minus the square root of 8 all over 2. Okay, biggest mistake, this is all over 2. We're not dividing 8 by 2 and 6 by 2 yet. First, we want to actually simplify this into an exact answer more so. So we want to take out any perfect root. So I know that 8 has a perfect root of 4. So I can think about this as root 4 times root 2, where this is perfect and is going to turn into a 2. All right, so now I have 6 plus or minus 2 root 2 all over 2. So everything is pretty simplified, but now we can deal with the denominator and the numerators. So I want to make sure to divide every term by 2. So 6 divided by 2, it's going to leave me with 3. 2 divided by 2 is going to cancel out to a 1. So my final answer will be 3 plus or minus the square root of 2. Final. All right, so that's it. Hope that this was helpful. Enjoy studying. I hope you guys all rock out on your test. Good luck. Okay, hold on.